All right, we've looked at converting from log form to exponential form and from exponential form back into log form, which will be useful in a couple sections. We're going to look at two objectives here now. One is 5.3.3, which is evaluating logarithms by hand when they're nice. And then we'll look at 5.3.2, which really should be in the other order, but that's going to be using our calculator when we have some uglier logarithms. Remember what a log means. It means that this base to that power equals this thing inside. So log base 2 of 16 is a question. What exponent would you put on the 2 to get 16? Which means how many 2's would you multiply together to get 16, which hopefully, if you've got any number sense, you know is 4. If not, try it in a calculator. Do 2 times 2 times 2 times 2. If you get 16, that's the right answer. How many 5's would we have to multiply together to get 125? Well, 5 times 5 is 25. Multiply that by 5, you get 125. So 3. So logarithms really aren't any more difficult than multiplying and counting. You just got to remember what they mean. Log with no base means log base 10. 10 to what power would be 100? 10 times 10, that's 2. Here, natural log of e would be log base e of e. And e to what power would be itself? Of course, 1. I didn't realize there was going to be a countdown here. That was not intentional, nor is it meaningful. Natural log of 1 means e to what power would be equal to 1. And if you don't remember, anything to the 0 power will be 1. So 0. And that's true for any base. That's why I had written down here the log with any base, log base 10, log base e, log base 7 of 1 will always be 0 because anything to that 0 power will always equal 1. And there's another rule that kind of goes along with that and goes along with this one here, is that the log base something of itself is always going to be 1 because anything to the first power will be itself. So here we got log base b of b. B to the first power is b. Anytime the base and the thing inside, the argument are the same, then that's going to be 1. From here on down, these are more stuff that you're going to run into, some of in my math lab. They're not the kind of thing I really care about. They're not going to be something I give you on a test, but I want to make sure you get an example of them so that you can make it through the My Math Lab homework successfully. They're not difficult. None of them are difficult here. 5 to what power would be 5 to the 4th power? This is really kind of the easiest one of the bunch. It's just written in a weird way. 5 to what power would be 5 to the 4th power? Of course, it's going to be 4. Here, log with no base means log base 10. 10 to what power would be 10 to the negative 7th power? Almost a trick question because it's so easy. These are a little more interesting here. Log base 49 of 7. Well, probably 2 jumps into your head because you know that 7 squared is 49, but they're not in the right order here, right? It's not 7 to the 2nd power is 49. It's the other way. The square root of 49 is 7, and the power that gives us the square root is power 1/2. So when you run into log base something of its own square root, the answer will be 1/2 because something to the 1/2 power is the square root of that thing. And that's true here also. Natural log means log base e. E to what power is the square root of e? That's the 1/2 power. And the last special case here, log base 2 of 1/4. Now log base 2 of 4, you know, would be 2 because 2 squared is 4. But this 4 is in the denominator. And hopefully you remember what sends something to the denominator when we're talking about exponents. That would be a negative. So negative 2. 2 to the negative 2 power is 1/4. All right. Next time, we'll talk about using the calculator on the real simple ones.